Stoichiometric calculations. When doing chemical calculations, it is critical to remember that the reaction relates the numbers of moles of the various reactants and products. It does not relate directly the number of grams of the substances. So any calculation that uses the amount of one substance to find the amount of another must go through the number of moles. For example, given the grams of substance A, we can use the molar mass of A to find the number of moles of A. From the number of moles of A, we can use the mole ratio, formed from the coefficients of A and B in the reaction, to find the number of moles of B. And the number of moles of B can be used with the molar mass of B to find the grams of substance B. If we start with 1.00 grams of C6H12O6, glucose, we calculate the moles of glucose, use the coefficients to find the moles of water, and then turn the moles of water to grams. There are many different pieces of data that the number of moles of a substance can be determined from. Some examples are mass. Moles equals grams over molar mass. The mole ratio converts moles of the given into moles of the unknown, which can be used to find the grams of the unknown. Pressure, volume, and temperature of a gas, moles equals PV over RT, can be used to find moles and produce pressure, volume, or temperature of a gas. Molarity and volume of a solution, moles equals molarity times liters, can be used to find moles and determine the volume or molarity of a solution. The number of atoms or molecules, moles equals number of molecules over Avogadro's number, can be used to find the moles, and then to determine the number of molecules or atoms. We can actually use any one of these four sets of information to find any other one of these four sets of information. In fact, any information, and there are more besides these four, that can be used to calculate the number of moles of something can be used as a way to start this process and be used to find something that can be determined from the number of moles. Limiting reactants. If I'm making cookies, I can only make cookies until I run out of one of the ingredients. Once we run out of sugar, we'll be unable to make any more cookies. In this case, the sugar would be the limiting reactant because it limits how many cookies you can make. In a chemical reaction, the reaction will stop when one of the reactants gets used up. Once that reactant is consumed and the reaction stops, no more products are formed. In this case, the H2 is the limiting reactant. In this example, O2 would be the excess reagent. The excess reagent is the reagent that is left over. When you are doing a stoichiometry problem, it is important to be able to recognize whether it is a limiting reactant problem. If you are given information about more than one of the reactants, then the problem is a limiting reactant problem if the information you are given is enough to be able to calculate the number of moles of more than one of the reactants. To do a limiting reactant problem, determine the moles of each reactant about which you have enough information. Then use the mole ratio to find the moles of the unknown you are looking for. Do this for each reactant. If there is more than one unknown, use the same unknown for all the given reactants. Whichever reactant produces the least amount of the unknown is the limiting reagent. The excess reagent is ignored. Theoretical and percent yield. The theoretical yield is the maximum amount of a product that you can get, given the amounts of reactants you have. It is what we get as the answer to the stoichiometry, that is the four-step calculation. The actual yield is what is actually produced by the reaction. It is always measured and cannot be calculated. The percent yield is the actual yield divided by the theoretical yield and multiplied by 100 to convert to percent.